Did an eye just appear next to your near-end crosstalk result? It's nothing to worry about, it's called the 4 dB rule. Let me explain how it works. So here we see I next to near-end crosstalk telling us that the 4 dB rule has caused a situation where the entire measurement has been ignored. I is not for ignored, it's actually meant for information only. You see the same for return loss as well. That's the 3 dB rule, which I've already covered in a previous video. Let's go and look at the worst performing pair. Pair 1236. Now what the standard says is that every frequency point for insertion loss on 3.6, we need to look at it, and if it's less than 4 dB, then we're going to ignore that near-end crosstalk measurement. And when that happens, at every frequency point that evaluation happens at, we turn the limit line from red to black. Given that the entire limit line is black, that suggests the insertion loss for pair 3.6 never actually reached 4 dB. Let's take a look. And indeed, at 250 MHz, our insertion loss was only 1.6 dB, hence the entire measurement was ignored. Now the 4 dB rule is only applied to the ISO and the EN standards. It's not applied to the TIA standard. Let's go and look at another example. So in this example here, we see an asterisk next to the near-end crosstalk result. That's indicating that it's marginal, but it did pass. Let's go and look and find out the worst performing pair combination. F3. And here that we see that part of the limit line is black and part of it is red. But you'll also notice if we scroll through the pairs, it actually went through the limit line, but it didn't come up with a fail. Why is that? Well, because in this range here, you'll notice the limit line is black. What that means is, along this entire frequency range here, the insertion loss for pair 7.8 never actually reached 4 dB. So let's go and look at pair 7.8. And indeed, at 493 MHz, it's 3.7 dB, and if I keep going, it never actually reaches 4 dB. So for that pair combination of crosstalk, the entire frequency range is ignored. Now, as I indicated earlier, this 4 dB rule only applies to the ISO and the EN standards. It does not apply to the TIA standard. So when I ran this exact same measurement again against the TIA standard, of course it failed. And now our worst performing pair is 3.6. Notice the entire limit line is red, and hence the fail there. If I go back up to my ISO standard, and I look at that near-end crosstalk reading again carefully, and I'll try and find a pair where this shows it better. Part of the limit line here is actually red, and I'll see if I can zoom in on that. So here it's actually red, and here it's black. Where it turns from black to red, that's where the insertion loss changed from 3.9 dB to 4 dB. So what we're trying to show here is that when your limit line is red, here, we get to evaluate the near-end crosstalk result. If the entire limit line is black, then we ignore the near-end crosstalk result entirely.